graphic enters a network interface card in a binary form, one frame at a time. So there's a here, as you can see here, we have source IP, source port, and here Ethernet, Ethernet 2, source address, and so on. Type IP version 4, Internet Protocol version 4, flags, time to live 1, protocol UDP, and so there's so much information that we will need to analyze, right? So while the space, the Wireshark uses the Enhanced Packet Analyzer (EPAN), which decodes the bits into human-readable format. So let me take my Gromit to draw things on the screen, and here apply. So this is our bits. So these are the hex codes and so on. So obviously you can't read this in your bare eyes, and there's some information about that. And here, after getting this raw information, Wireshark translates it to with Enhanced Packet Analyzer Engine, which decodes, as I said, decodes the bits into human readable format here. Perfect. So now we will step through the APAN. So prior to 2006, Wireshark was called Eternal. So yeah, so the name has changed, however, as obviously the main core is the same, right? So EPAN is the packet analyzing engine for Wireshark that use dissectors, also known as decoder. The dissectors provide information on how to create the protocols in the proper format according to appropriate request for Commons RFC or other specification. So EPAN contains 4 main APIs, which is the first is protocol tree, dissectors, sorry for this, dissectors, dissector plugins, and display filters. So we have the protocol tree, which is this displays the detailed analysis of a single packet. We also have the sectors. So these provide information how to break down the protocols into proper format. We also have the sector plugins. So these use the sectors as a separate functions. And lastly, we have display filter, and this allows you to filter captured data. In most cases, Wireshark is able to correctly identify and dissect the protocol. However, there are times when you will need help. Wireshark decode the protocols, right? So you can achieve this by right-clicking on the frame here, and here you will go to decode as here, which will bring up this dialog. Here, as you can see here, we have several options here. So once in this window, you can modify the values to match the appropriate protocol. And this function is very useful when protocols either don't have a dedicated port or they are running on a different port compared to the usual. For example, you should use decode as when the HTTP is running on port 8080 instead of port 80. So once the bits have been converted into proper format, the next step is to display the results in human readable format. So now let's display the result here. So in Wireshark, along with the many other packet analysis tools, there are many options to enhance your graphical experience. So when you open a packet capture in a Wireshark, the default layout for the main display is in the 3 panels. Which is here. So let me take my pen again. So this is our, can you see it? Sorry. Please come. I guess we here. So toggle painting home, shift home. Yes, perfect. So here, this is our packet list. This tab we are using for is our packet list. These are the packet details here. These are the packet details, and obviously these are the raw format, which is a packet bytes. So the packet list here, this is a list of all captured packets packets where each line represents a single packet, as you can see here: broadcast, IP, destination source, protocol, length info, and so on. Everything has a source and destination, right? This was so philosophical here. So we also have packet details. So here, this is a packet details. This displays the details of a single packet and includes the protocols and field values. It also displays Wireshark specific hints. For example, when examining the TCP here, let's choose some TCP here. TCP. Oops. Of course, we have to use here. So this is our TCP. So when you examining a transmission control protocol header, you will see the stream index listed below the source and destination force, right? So, however, there is a no field value called the stream index, and a stream is a communication between two endpoints that compromises the endpoint A socket and endpoint B socket. So to help to keep track of all those streams, Wireshark lists each stream in a TCP header. Here now we have a transmission control protocol. Let's actually, here you can also protocol. Here, open this tab, transmission control protocol, and as you can see here, stream index 1. Let's can we here, yeah, stream index 1. So I hope you see clearly. So stream index 1. So this is what I've called endpoint A socket and endpoint B socket, which is source and destination ports, over there is no field called stream index in some cases, and that's how you can bring it up. And we also have packet bytes. This is a hexadecimal representation of a single packet, as shown, as you can see here. And any plain text data is displayed on the right hand side, as you can see here. This link.net something here. Yes, let's get some meaningful text here because it happens sometimes. All right. Okay. You can also use your arrow keys to get those information, and okay, here, perfect. That's it. That's our request, the HTTP request. So this is a hexadecimal representation of a single packet, as shown here, and any plain text data is displayed on the right side, and these are the hexadecimal. This turned to our text. And after that, if it's not enough for you, the Wireshark like analyzes it itself, and here request version, request URI, request method, post request, and so on. In next lecture we will also learn how to change the layout, how to analyze the package capture, and so on. I'm waiting you in next lecture.